Howdy, all you cool cats and kittens. And if you did not just get my reference to Tiger King, then we cannot be friends, because that has been the best part of Coronication for me thus far. Let's get started with part 3 of section 7.1. Again, we're just doing more practice with the trigonometric identities. And let's start with example 1. Both sides look interesting. I would say maybe the left side might be a little bit more challenging, so I think that's where I'm gonna start. I could start with foiling maybe. I don't know if that would help. I think what I would like to do is maybe start with just changing everything to sines and cosines and seeing what's gonna happen. So I've got sine of alpha, that's the Greek letter, minus, I'm going to change tangent to sine of alpha over cosine of alpha. And then in the second parentheses, I have cosine of alpha minus, and I'm going to change cotangent of alpha to cosine alpha over sine alpha. All right, so successfully changed all of my terms to sines and cosines. Let's look at the first set of parentheses. I think I probably need a common denominator, which is going to be cosine alpha. And so fraction number 1 is missing that. So I'm going to have to put a cosine alpha in both the numerator and the denominator. So all I'm doing so far is working inside of that first set of parentheses, coming up with a common denominator. I think I'm going to do the same thing in the second set of parentheses. That common denominator is going to be sine alpha, and fraction number 1 is, it's not a fraction yet, but it was missing that, so it's going to get a sine alpha in both the numerator and the denominator. All right, so now that I have common denominators, let's combine it so that we have a single fraction in each one. So I have sine alpha cosine alpha minus sine alpha all over cosine alpha. There's our first set of parentheses. That's a mouthful. Second set of parentheses, I have cosine alpha sine alpha minus cosine alpha all over sine alpha. All right, so let's go back to the first set of parentheses. If I look at the numerator, I see that there is a greatest common factor of sine alpha. So I'm going to take sine alpha out, and that's going to leave me with cosine alpha minus 1. Again, all of that is over cosine alpha. And that's being multiplied times the second set of parentheses, which its numerator also has a GCF. This one is cosine alpha, so I'm going to take it out. That's going to leave me with sine alpha minus 1. And again, all of that is over its denominator of sine alpha. So now we have some good news, because I'm going to multiply those fractions, so I'm going to look for things that I can cross cancel. I have a sine alpha in both the numerator and the denominator. I have a cosine alpha in both the numerator and the denominator. So I'm left with cosine alpha minus 1 times sine alpha minus 1, which works out perfectly because that is what's on the right hand side as well. Could there have been an easier way to do that one? Maybe. That's just the first thing I thought to do. All right, example 2, definitely going to be starting over here on the left because it is way more complex than what's on the right side. I kind of like what I just did in the last one, change into sines and cosines. So I think I'm going to do that over here as well. So I'm going to change that tangent x to sine x over cosine x. I'm going to change the tangent y to sine y over cosine y. So that takes care of the numerator. I'm going to do the same thing for cotangent. So cotangent x, I'm going to turn that into cosine x over sine x. And then cotangent y, I'm going to change that to cosine y over sine y. All right, so clearly I have a complex fraction. Let's work with this numerator. And in that numerator, I have two separate fractions, both with different denominators. So I'm going to have a common denominator. I need a cosine x and a cosine y. So fraction number 1 is missing the cosine y, so I'm going to just go ahead and do that in both the numerator and the denominator. Fraction number 2 is missing cosine x, so I'm going to go ahead and put that in the numerator and the denominator. And then let's go ahead and take a look at the big denominator. Again, we need a common denominator down there. It's going to be sine x, sine y. So the first fraction is missing a sine y, so I'm going to go ahead and multiply numerator and denominator by sine y. Fraction number 2 is missing a sine x, so I'm going to go ahead and multiply. Oh, I said x, but I wrote y, didn't I? There we go. Okay, so let's rewrite this as a single fraction. So I've got cosine y sine x plus sine y cosine x all over that common denominator of cosine x cosine y over, now I'm going to work in my denominator here, and I have sine y cosine x plus cosine y sine x all over sine x sine y. All right, let's change this to multiplying by the reciprocal and see what happens. And I'm kind of running out of space, so I'm just going to bring it on up here. So my first fraction is going to stay the same. So cosine y sine x plus sine y cosine x all over cosine x cosine y. Now I'm going to turn this into multiplying by the reciprocal. So my numerator is now going to be sine x sine y, and my denominator is sine y cosine x plus cosine y sine x. All right, so let's look at what we have. Actually, this entire thing right here, cosine y sine x plus sine y cosine x plus sine y cosine x. All of that is going to cancel out. It's exactly the same thing. That leaves us with sine x sine y over cosine x cosine y. Now if I look at the ones that have the same variable, I have sine x over cosine x, which turns into tangent x, sine y over cosine y, that turns into tangent y, and that's exactly what we should have ended up with. Again, maybe there was an easier way to do that one, but that was the first thing that clicked in my head. Sometimes I go with whatever I think of first. All right, example 3. Definitely think that that side is going to be more challenging. You know, there's a couple things I can think to do. We could jump straight into changing things to sines and cosines, because clearly our final answer needs to be sines and cosines. But I kind of like that I'm looking at the denominator and I'm able to tell that that's a difference of squares. I wonder if that would help me out. Let's see. Let me factor that real quick. And I'm just going to do the bottom real quick. So since that's a difference of squares, that's going to factor out into tangent v minus cotangent v onto tangent v plus cotangent v. So all I've done so far is taken the denominator and use the difference of squares pattern. And my numerator I'm not going to change. And I see some good news, because tangent v minus cotangent v is a factor that occurs in both the top and the bottom. So I have 1 over tangent v plus cotangent v. All right, well, we still aren't where we want to be, but it looks maybe a little bit more simple than it did from the start. This might be a good point to change into sines and cosines. So tangent v, I'm going to change that into sine v over cosine v. Cotangent v, I'm going to turn that into cosine v over sine v. I'm definitely going to need common denominators in that denominator. The common denominator is going to be a cosine v and a sine v. So fraction number 1 is missing a sine v, so I'm going to multiply both the numerator and the denominator by that. Fraction number 2 is missing a cosine v, so I'm going to multiply both the numerator and the denominator by that. And I'm going to run out of room, so I write too big, I think. Okay, so we still have 1 over. All right, I'm going to go ahead in the denominator and put that common denominator, which we said is sine v cosine v. And let's look at the numerator. Sine v times sine v is sine squared v. Cosine v times cosine v is cosine squared v. Ooh, that's one of those Pythagorean identities. That's going to turn into a 1. So now I have 1 over sine v cosine v. And now I'm going to turn this into multiplying by the reciprocal, which is going to give me sine v cosine v, which is what we wanted it to be. All right, so you could have started at the very beginning by changing to sines and cosines. To me, this way made a little bit more sense, but that's definitely doable. Let's move on over to example 4. I'm not sure that there's one side that is trickier than the other. So since I've been starting on the left a lot, I'm just going to keep up with that pattern. So let's see. We have cotangent x plus 1 over cotangent x minus 1. And I know that at the end of the problem, I want to have tangents and not cotangents because I want it to look like this. So what if instead of changing to sines and cosines, I change to tangents? Because I know cotangent x is the reciprocal of tangent. And so I'm going to rewrite both of those cotangent x's as such. And then I'm probably going to need a common denominator, right? So the 1 is going to turn into tangent x over tangent x, and it's going to be the same in the denominator as well. So let's see what we have. In our numerator, we have 1 plus tangent x over our common denominator of tangent x. In the denominator, we have 1 minus tangent x over our common denominator of tangent x. So here again, we've got that complex fraction. I'm going to turn it into multiplying by the reciprocal, so I'm going to keep the first fraction the same. I'm going to change from division to multiplication, and the second fraction, we're going to flip it into the reciprocal. And good news, tangent x is going to cancel out because we had the same factor in the numerator and denominator, and we're left with 1 plus tangent x over 1 minus tangent x. That one wasn't too bad. All right, example number 5. Again, I'm not so sure that one side is trickier than the other, but just for the sake of doing something different, I'm going to switch on over to the right side. So one thing we could do is start by writing sines and cosines if we wanted. Secant squared x would be 1 over cosine squared x, and cosecant squared x would be 1 over sine squared x. And then we'd need a common denominator, wouldn't we? Which would be cosine squared x and sine squared x. So the first fraction is going to need a sine squared x. The second fraction is going to need a cosine squared x in both the top and the bottom. So as I put it over a single denominator of sine squared x, cosine squared x, my numerator is sine squared x minus cosine squared x, which is a difference of squares. I could factor that. So that would be sine x minus cosine x times sine x plus cosine x. Again, all of this is over sine squared x, cosine squared x. But I feel like I am making this problem way harder than it has to be. So you know what? I think I'm going to go back to the drawing board on this one. I might have to come back to it, but for right now, let's shelve it and see what we can think of. Let's go back real quick and remember those Pythagorean identities. So we have sine squared x plus cosine squared x equals 1. That's the one that I for sure have memorized. If I go through and if I go through and divide everything by sine squared x, I would get 1 plus cotangent squared x equals cosecant squared x. If I go back to the original one and divide everything by cosine squared x, I would have tangent squared x plus 1 equals secant squared x. Let's see if one of those is going to help us out. So I'm starting over here, but at the end of the problem, I want to have tangents and cotangents. So what do I know about secant squared x? Well, I know that it's equal to tangent squared x plus 1. So let's use the substitution property. I'm going to plug tangent squared x plus 1 in place of secant squared x. Then I'm bringing down my minus sign. Now let's replace cosecant squared x. Guess what it's equal to? It's equal to 1 plus cotangent squared x. So before I can combine things, I have to distribute the minus sign, right? So I have tangent squared x plus 1 minus cotangent squared x. The 1 minus 1 is going to cancel out. We're going to be left with tangent squared x minus cotangent squared x. Ooh, which is exactly what we wanted. So you see, sometimes you try something and it doesn't necessarily work to your advantage right away, and then you have to brainstorm and try something else. Certainly this was easier than what I was going to do. I could have kept going, but I think that would have gotten to be quite an ugly problem. All right, last one, y'all. Example 6. I don't know. I think I'm going to go back over here to the left. I don't know that either side is really that much challenging. But let's maybe rewrite cosecant, because I know that cosecant is 1 over sine x. And I'm probably going to want a common denominator. So this guy right here needs a denominator of sine x. So I'm also going to have to multiply the numerator by sine x, which is going to turn this into sine squared x over sine x. So if I were to write this as a single fraction, I have 1 minus sine squared x over sine x. Let's go back to these Pythagorean identities. What do I know about 1 minus sine squared x? Let's go back to this first one. If you moved the sine squared x over by subtraction, what would be left over here? Well, a cosine squared x. So I'm going to replace the 1 minus sine squared x with cosine squared x. So look at what I have and look at what I want to have. I want to have cosine x, cotangent x. Let's talk for a moment about cosine squared x, because remember that just means that you have cosine x that's being multiplied by itself. And I still have this denominator of sine x. Well, what happens right here? What can I do with that cosine x over sine x? I can change that to cotangent x. So I still have the cosine x from the one cosine, but now this second cosine over sine has turned into cotangent, which is exactly what we wanted. All right, so we have spent 3 days working on these identity problems. I would love for y'all to let me know how you're doing and if you need any extra help. So Wednesday, you guys are watching this video and doing more practice. Tomorrow we have a quiz meeting at Zoom at 9:15. So here's what I would ask of you guys. If you have any major questions that maybe you want answered before tomorrow, shoot me an email. I would be willing to do a Zoom session on Wednesday instead of waiting until Thursday, because when we meet on Thursday, it's really just going to be time to take the quiz, not to answer questions. So let me know if you would like a Zoom session sometime on Wednesday. I can set that up. And if nobody lets me know anything, then I will just enjoy my time reading a book. That sounds really nice right now. But I would love to help you, so let me know, and have a good day.